Greetings. My name is Egon Chalakian, and I am here to speak the truth. A truth that concerns each and every one of us. Some time ago, I made a public statement about an invisible threat infiltrating our bodies, our air, our water, and even our minds. I am referring to micro and nanoplastics. We, the volunteers of ALLATRA, sounded the alarm about this threat 2 decades ago. At the time, few were willing to listen. Today, science, including some of those who did hear us back then, has confirmed the warnings we issued. Nanoplastic does not merely pollute. It exacerbates diseases and disrupts food chains. New research reveals that this threat is far more serious than we initially imagined, and it is now reshaping everything, from the climate to microbial ecosystems, from human health to the future of civilization itself. We are not standing at the edge of the abyss. We are already in free fall. Today, I will speak about how we squandered the window of opportunity for simple solutions and how political barriers are now obstructing new ones. I will share what science has discovered in the intervening years and examine whether we, as a global community, can still avert this threat. To grasp how deeply we are entangled in this unfolding catastrophe, let us first understand what micro and nanoplastics are and how they became the enemy of our own making. Since the onset of mass plastic production in the 1950s, the world has manufactured more than 9 billion tons of plastic products. Of that amount, approximately 5 billion tons have ended up in landfills. About 250 million tons have reached a nanoplastic state in our atmosphere due to the incineration of 1 billion tons. Up to an additional 2.5 billion tons were improperly disposed of, meaning they have already entered our biosphere. In other words, the vast majority of all plastic ever produced has not disappeared. It has simply changed form. And now it's in the water, in the soil, in our food, and inside our bodies. Each year, more than 400 million tons of plastic waste are generated globally. Every minute, the equivalent of 1 full garbage truck's worth of plastic is dumped into the world's oceans. And with each passing year, this flow continues to accelerate. Estimates indicate that by 2040, if current trends persist, between 23 and 53 million tons of plastic will be entering aquatic ecosystems annually. By 2050, the total mass of plastic in the oceans may reach 12 billion tons, roughly equal to the weight of all the fish in all the oceans on Earth. As I've already noted, plastic does not simply disappear. Under the influence of sunlight, waves, sea salt, and mechanical friction, it breaks down into microparticles, less than 5 millimeters, and nanoparticles less than 1,000 nanometers, a thousandth the width of a human hair. This disintegration does not render it harmless. On the contrary, it transforms plastic into a nanomaterial that is virtually undetectable but easily penetrates living organisms. It is crucial to understand that the primary reservoir of plastic, and therefore of micro and nanoplastics, is the ocean. The ocean is the largest organ of our planet. It regulates the climate, produces oxygen, and sustains life. Just consider this. The ocean is the most vast and vital part of our world, and it is precisely this essential organ that has been inundated by one of the most inconspicuous yet most destructive enemies, nanoplastic. We have contaminated the planet's life-sustaining organ with an invisible toxin. Up to 350 trillion particles are in the ocean's surface layer alone. Yet biologists acknowledge that 90% of nanoplastics are so small that our instruments cannot detect them. As water evaporates, microplastic rises into the atmosphere from the surface of the ocean. Each year, approximately 136,000 tons of microplastic are carried to coastal regions by sea breeze alone. Up to 25 million tons of micro and nanoplastics are transported annually across thousands of kilometers by ocean air, sea spray, snow, and fog, crossing countries, continents, and oceans. Global contamination by micro and nanoplastics continues to grow at an exponential rate in water, in the atmosphere, and in our food supply. As a result, we inhale and ingest plastic with every breath we take and every sip we consume. Microplastic has already been detected in sea ice, rainwater, soil and dust on agricultural lands, in drinking water and food. It has been found even in products considered healthy, fruits, vegetables, and even in salt. In the atmosphere, even in the alpine mountains, the tundra, and polar snowcaps. In the bodies of 1,300 animal species, including apex predators, and most disturbingly, every organ of the human body. Some mistakenly believe that halting plastic production could solve the problem, but I must disappoint you. The data show that even if we were to completely cease plastic production today, the breakdown of already existing plastic into nano and microparticles would continue. The amount of plastic already present on our planet is sufficient to devastate our biosphere many times over. This is the central trap of our civilization. We created plastic to last forever, yet we fail to consider that forever would one day actually arrive. What makes plastic a silent killer? The primary danger of micro and nanoplastics lies in their unique ability to accumulate electrostatic charge on their surface. The Alatra Scientific Group warned about this phenomenon 20 years ago. How do plastic particles acquire this charge? It occurs through manufacturing processes, friction and contact with other surfaces, changes in surrounding environment, such as pH, ionic composition, and humidity. Depending on their chemical structure, plastic particles can acquire either a positive or negative charge. The surfaces of these particles may undergo ionization, imparting a stable electrostatic activity to them. This means that nanoplastic particles are not merely inert polymers. They are charged bodies actively interacting with their environment. In the atmosphere, charged nanoplastics acts as a condensation nucleus, accelerating cloud formation and causing droplets to freeze at temperatures 4 to 10 Celsius higher than usual. This leads to abnormally large hail, anomalous precipitation, and disruption of the hydrological cycle, affecting weather patterns, aviation, and agriculture, and reducing the predictability of rainfall. This means microplastic is already a climatically active material. It participates in the weather, in rain and snow models, in flight safety. It influences how clouds freeze, where precipitation falls, and in what form. Inside the human body, charged plastic particles function as molecular saboteurs. Our bodies are governed by electricity. The brain doesn't think in words. It thinks in electrical impulses. The heart beats because cells transmit electrical charges to one another. Muscles move when a current arrives. Even the immune system is coordinated through ionic signals and voltage differentials. We are quite literally an electrical system. But when tiny plastic particles, especially charged ones like nanoplastic, enter the body, they can severely disrupt that system. Positively charged nanoplastic particles penetrate cells and inflict damage from within. They can destroy mitochondria, the cell's power plants, trigger oxidative stress, and initiate programmed cell death, apoptosis. Negatively charged nanoplastic particles accumulate in immune cells, causing persistent low-grade inflammation and acting as a constant irritant that never clears. In addition, charged nanoplastic interferes with the normal function of ion channels and receptors, the gates through which cells receive signals, disrupts the natural electrical fields within tissues, generates noise in the body's bioelectrical system, much like radio interference disrupting signal transmission, distorts intercellular signals, impairing normal cellular function. As a result, the body begins to respond inappropriately, triggering inflammation where there is no threat, or failing to recognize danger when it is present. In other words, such particles can scramble the body's entire electrical communications system, and when that system fails, everything suffers, from cognitive function and heart rhythm to the immune response. All of this leads to systemic failures within the body, disrupting the function of the heart, brain, endocrine, and immune systems. Nanoplastic thus acts as an active agent of destruction. Charged plastic molecules literally adhere to tissues, infiltrate cells, disrupt their functions, interact with DNA, and trigger chains of inflammatory, oncogenic, and neurodegenerative processes. It is the electrostatic charge that allows nanoplastic not only to penetrate the body's protective barriers, but to remain inside the cells of living organisms indefinitely. It is precisely because of this charge that micro and nanoplastic penetrates cells and is now found in substantial quantities in the bloodstream, brain, placenta, sperm, and lungs. Such systemic accumulation of nanoplastic in the body leads to a broad spectrum of serious illnesses, including oncological conditions, including cancers of the lungs, breast, and colon, neurodegenerative diseases such as dementia, Alzheimer's, Parkinson's, and multiple sclerosis, autoimmune and chronic inflammatory disorders, infertility and reproductive dysfunction in both men and women, including erectile dysfunction and reduced fertility, endocrine disorders, DNA damage and cellular instability, respiratory diseases including microfibrosis, asthma, and elevated cancer risk, developmental disorders and mutations in children. These processes are not episodic. Plastic particles accumulate in the body day after day. This is precisely why nanoplastic has become the #1 killer today. The amount of micro and nanoplastic is growing exponentially. Up to 81% of tap water and 100% of bottled water already contain plastic particles. It is present in our food and especially abundant in the air we breathe. As a result, more and more micro and nanoplastics are entering our bodies. At this rate of progression, we will inevitably reach a phase in which the majority of children are born with severe developmental disorders. And every individual, without exception, suffers from neurodegenerative diseases, chronic inflammation, cognitive impairment, and behavioral abnormalities. Micro and nanoplastic is, in essence, becoming a substance that interferes with the very nature of the human being. Our memory, our thinking, our will, and our ability to reproduce. To gain a deeper understanding of everything I've just shared with you, and to learn more while expanding your knowledge, I encourage you to read the report, Nanoplastic in the Biosphere, From Molecular Impact to Planetary Crisis, published on ALLATRA's official website. This material was prepared in collaboration with two universities, the Bolivian Catholic University and Juan Misael Saracho Autonomous University, which served as institutional peer review partners. The report was also developed in collaboration with a scientific contributor, the international project Creative Society. Moreover, in May 2025, I visited the Vatican together with Marina Avstinova, the president of ALLATRA. The visit included a private audience with His Holiness Pope Leo XIV. During this visit, the report, Nanoplastic in the Biosphere, From Molecular Impact to Planetary Crisis, was presented to the Vatican office and personally to the Secretary of State, Cardinal Pietro Parolin. The creation of this report was, in many ways, inspired by the blessing His Holiness Pope Francis bestowed upon ALLATRA in 2024. I also wish to inform all people of sound mind that the President of ALLATRA, Marina Avstinova, along with her work and the work of ALLATRA, has once again been highly recognized by the Vatican. His Holiness Pope Leo XIV has granted an apostolic blessing, which extends to Miss Avstinova, her loved ones, and all volunteers of ALLATRA. I extend my deepest gratitude to both our Vatican family of supporters and to His Holiness Pope Leo XIV for their acknowledgement of the work undertaken by ALLATRA on behalf of all humanity. I would like to emphasize that this report is the result of a comprehensive interdisciplinary analysis encompassing the ecological, climatic, medical, physical, and chemical dimensions of the destructive influence that micro and nanoplastic exerts on the biosphere and human health. The report presents scientific data on the scale and consequences of micro and nanoplastic pollution, including the rapid spread of micro and nanoplastics across all environments of the biosphere, from the depths of the oceans to the atmosphere, the detection of plastic particles in water, food, and the human body, regardless of geographic location, the integration of plastic particles into food chains and their ability to bypass natural barriers, including penetration into the brain and placenta, the accumulation of nanoplastic in organs and tissues, with effects that may manifest years later. The abnormally destructive impact of micro and nanoplastic on human health, including inflammation, DNA damage and mutations, disruptions of the endocrine system, accelerated cellular aging, impaired memory and cognitive function, reproductive disorders and infertility, a rise of oncological diseases, and most alarmingly, the effect of micro and nanoplastic on children, beginning in the womb, impairments in brain development, mental health, and the immune and nervous systems. Why is the publication of this report so important? Because for the first time, a single document provides a comprehensive examination of data on the spread of micro and nanoplastics in the biosphere, their infiltration into food chains, and their destructive impact on both human health and ecosystems. The report places particular emphasis on approaches to addressing the problem, including innovative proposals from the ALLATRA scientific community. The strategic direction for counteracting this threat proposed by the ALLATRA scientific group in the report is the development of methods to neutralize or shield the electrostatic charge of nanoplastic, one of the primary factors behind its toxicity. As you already know, charged nanoplastic particles actively interact with cell membranes, proteins, and genetic material, forming persistent molecular bonds. Reducing the electrostatic activity of micro and nanoplastics could significantly diminish their harmfulness and slow their accumulation in the human body. According to the report's authors, shielding or neutralizing the electrostatic charge could reduce the potential danger of micro and nanoplastic by at least 50%, making this line of research critically important. This would create the critical window of time needed to develop more comprehensive strategies for diagnosing, preventing, and eliminating micro and nanoplastics from the human body, and for cleansing the biosphere. In this context, research in the fields of biophysics, nanotechnology, and molecular toxicology takes on particular significance. Thus, in effect, response to the threat of micro and nanoplastic contamination requires not isolated interventions, but a global and interdisciplinary approach. Coordinated efforts are essential across scientific research, technological innovation, regulatory policy, and international cooperation. Plastic pollution must not be viewed as a narrow environmental issue, but rather a systemic challenge that affects public health, security, resource availability, and the resilience of social infrastructure. Thanks to the ALLATRA scientific group, we are now not only able to recognize this crisis, we are capable of moving toward its resolution. The uniqueness of this report lies in its comprehensive interdisciplinary approach, integrating data from physics, chemistry, biology, and medicine. This synthesis allows the issue of micro and nanoplastic to be understood as a civilizational challenge, one that demands solutions across multiple levels. Today, the global community is gradually beginning to grasp the true scale of this threat. Studies are now emerging that confirm what we warned about 20 years ago. On the one hand, this brings a measure of hope. But on the other, it reveals that as a civilization, we have lost 2 critical decades. We could have stopped all of this back then. At that time, there was a clear path to countering the plastic threat. I believe many of you remember the technology known as AWG, the atmospheric water generator, which once held the promise of purifying the air from contaminants, including plastic. It was an innovative beacon of hope, a technology that, if deployed globally, could have preserved the health of lives of billions and helped cleanse the planet. But we missed that opportunity. In matters like these, the time factor is decisive. It is essential to understand that ALLATRA scientists first proposed using AWG to purify oceanic waters more than 20 years ago, at a time when the concentration of microplastic in the atmosphere remained extremely low. Back then, implementing such technologies could have delivered tangible environmental benefits without posing serious risk to human health. At that time, AWG could have been a lifeline. But today, given the elevated levels of nanoplastic in the atmosphere, it poses a danger. Widespread deployment of AWG technology under current conditions could significantly increase the concentration of microplastic in the air. The operational mechanism of AWG involves the condensation of moisture from the atmosphere, which is then replenished through evaporation from ocean waters. Since those waters now contain high levels of micro and nanoplastic, the moisture reintroduced into the atmosphere through this process carries with it microscopic plastic particles. As a result, in regions where these technologies are implemented, including major metropolitan areas, the concentration of nanoplastic in inhaled air could reach the same levels currently observed in coastal zones. This creates a serious risk of elevating airborne nanoplastic levels, posing a direct threat to human health and life. Inhaling nanoplastic contributes to its accumulation in the body, including the brain. This is a critical point. As I've already stated, of all the pathways by which plastic enters the human body, the most dangerous is inhalation, through breathing. When inhaled, nanoplastic particles travel directly to the brain via the olfactory nerves, reaching the region responsible for the sense of smell. This creates a shorter and more direct route to the brain than any other organ, where these particles ultimately settle and remain. Research shows that the highest concentrations of nanoplastic are found specifically in brain tissue, 7 to 30 times higher than in the liver or kidneys. In fact, nearly every deceased individual studied has been found to have up to 4,900 micrograms of plastic per gram of brain tissue, the equivalent of an entire plastic teaspoon. This means that our brains today consist of approximately 99.5% neural tissue and 0.5% plastic. The accumulation of micro and nanoplastics in the human brain leads to cognitive impairment, neural inflammation, oxidative stress, and dementia. In individuals who suffered from dementia, post-mortem studies have revealed nanoplastic concentrations up to 10 times higher than in those without the disease. In other words, if plastic constitutes about 0.5% of the brain in healthy individuals, it may reach up to 5% in dementia patients. Instead of 1 plastic teaspoon, they carry the equivalent of 10. And the majority of that plastic entered the brain through the respiratory tract. The catastrophic consequences of plastic oversaturation in the brain become strikingly clear when we examine the brain of a honeybee. Scientists have discovered that nanoplastic in the brain tissue of honeybees disrupts their memory, orientation, and cognitive function. The bee forgets where nectar is located and loses its way back to the hive. And this disorientation ultimately leads to the collapse of the entire colony. I would like to show a shocking image of a honeybee's brain containing a significant concentration of nanoplastic. In this photo, the level of visible micro and nanoplastic corresponds to the onset of disorientation, the development of neurodegenerative processes, and ultimately the bee's death. As you now know, nanoplastic affects the human brain in much the same way. It damages neurons, impairs cognition, and leads to neurodegenerative disorders. This raises a critical question. What is the threshold for the human brain? Because that threshold must certainly exist. How much plastic must accumulate in our brains before we, like the bees, begin to experience mass onset dementia, regardless of age, and start to perish from severe neurodegenerative diseases? Who can say how close we already are to that line? This is why living near open bodies of water, seas, lakes, rivers, is especially dangerous. Water evaporates, waves create spray, bubbles burst, and nanoplastic particles are ejected into the air. In coastal zones, plastic concentrations in the air are higher than in cities, which means that people living there are exposed to significantly more nanoplastic entering directly into the brain. These particles rise from the surface of the water, collect in the aerosol droplets, are carried by the wind, and when inhaled, enter the lungs and the brain, bypassing the blood-brain barrier. Against this backdrop, a growing number of scientific studies point to a direct link between chronic inhalation of sea air contaminated with microplastic and the risk of developing neurodegenerative diseases, including Alzheimer's and Parkinson's. But these are not the only dangers awaiting you if you decide to spend time by the sea. There is one more piece of news that may disappoint some, especially since it's currently summer in our hemisphere. However, you have the right to know information that could help protect your health and the health of your loved ones. When a person emerges from the sea, a thin film of seawater remains on their skin, and that water already contains micro and nanoplastic. Even if we cannot see it, it is there. Then physics takes over. Under the influence of sunlight, the body heats up and destructive processes begin to unfold. When exposed to light, nanoplastic generates aggressive free radicals. At the same time, static electricity is produced, and the plastic particles on the skin retain and amplify this charge. This creates a localized zone of electrostatic tension directly on the body's surface. Electrically charged plastic interacts with immune cells in the skin, which, as you may recall, also contain nanoplastic. The skin, as is well known, is the largest immune organ of the human body. Beneath its outermost layer lie structures responsible for primary immune defense. When this system is disrupted, autoimmune malfunctions begin to emerge. These may manifest as chronic skin inflammation, eczema, unusual allergic reactions, and other dermatological disorders. But the effects do not stop there. Once the skin barrier is compromised, the dysfunction spreads to other bodily systems. The respiratory and excretory systems are especially affected as they too come into contact with charged nanoplastic through the air and mucous membranes. As a result, what seems like a harmless day at the beach exposes the body to multifaceted assault, inhaling plastic, absorbing it through the skin, amplifying its effects through solar heating, and triggering a cascade of immune failures, some of which may not appear immediately. We think we are resting, but in reality we are initiating a slow-moving immune crisis, provoked by the combined forces of sun, water, and plastic. Now I'd like to share an especially alarming study. Presented at the 77th Annual Meeting of the American Academy of Neurology in 2025, it revealed that in U.S. coastal counties with high levels of microplastic exceeding 1,000 particles per cubic meter of water, there is an increased risk of cognitive decline, mobility issues, difficulties with self-care, and loss of independence. This means that living near open bodies of water increases the likelihood of developing neurodegenerative conditions. Another study found that, compared to individuals living near bodies of water with low levels of pollution, defined as a single speck of plastic dust per 200 bathtubs of seawater, people residing near highly polluted waters show higher rates of type 2 diabetes, greater risk of stroke, and increased incidence of ischemic heart disease. Here I would like to go into greater detail. In that study, water classified as having a low level of pollution was defined as a single speck of plastic dust per 200 bathtubs of seawater. That may sound negligible to you right now, but let's take a closer look and do some simple calculations. Let's assume one speck of microplastic has a volume of 1 cubic millimeter. That single speck breaks down into billions of nanoparticles. For example, if we consider a particle with a diameter of 100 nanometers, roughly 2 to 4 trillion nanoparticles would fit into just 1 cubic millimeter. For even smaller particles, around 10 nanometers in diameter, that number rises to 10 to the 15th, or 1 quadrillion particles. This means that even in a single glass of such clean water, you would be ingesting approximately 5 million nanoplastic particles. And as you already know, each of these particles, once inside your body, can damage your cells, triggering inflammation and disease. And yet, this is considered relatively clean water, a standard that hardly exists anywhere today. Practically everything around us is now a polluted body of water. This makes open bodies of water in coastal areas high-risk zones, where every breath delivers plastic to your brain. Living near them means breathing and drinking plastic that accumulates in your brain. Do we really wish to follow the fate of the honeybee? And now imagine if, under these conditions, we were to begin widespread use of AWG. Its mass deployment would further increase the concentration of charged nanoparticles in the air, intensifying their penetration into the lungs and brain. In other words, it would accelerate the destruction of the biosphere even more rapidly. No, AWG is no longer a technology of the future, but rather a bitter reminder of the opportunity humanity failed to have seized upon. Because of our inaction, we have lost time, and now we need new solutions, technologies capable first of neutralizing or shielding the electrostatic charge of plastic, and then of removing nanoplastic from both the biosphere and our bodies. This is our last chance to buy time. Everything I've shared with you up to this point already sounds like a catastrophe. But unfortunately, this is not the end of the list. Over the past year, science has taken a step forward and discovered just how rapidly and dangerously the nanoplastic threat is evolving. Have you ever wondered why? In recent years, we are increasingly facing a reality where antibiotics no longer work. Today, we can say with certainty that nanoplastic plays a direct role in the development of antibiotic resistance and helps bacteria mutate. Research from 2025 reveals that plastic is helping bacteria become resistant to antibiotics, fueling a crisis that modern medicine is struggling to contain. Why? Because plastic is an ideal platform for bacteria. Until recently, scientists already knew that microplastic serves as a convenient platform for bacterial colonization. On its surface, bacteria easily form biofilms, A biofilm is a dense, protective layer that shields bacteria from drying out, sunlight, immune system attacks, and most critically, the effects of antibiotics. It was also known that bacteria can survive on plastic longer than on other materials, sometimes for 3 days or more. All of this makes microplastic a key factor in the spread of dangerous microbes throughout the environment, in water, in soil, and at times even in food products. However, a recent study has led scientists to a critical discovery. Plastic aids bacteria not only physically as a kind of shelter, but also biochemically, functioning as a sort of power bank. Research has demonstrated in laboratory conditions that when bacteria come into contact with microplastic, they activate a special type of metabolism associated with electron transfer. Simply put, plastic particles can either donate electrons to bacteria or facilitate their transfer. This enhances the microbe's ability to survive under stress and accelerates their adaptation to antibiotics. This process is known as extracellular electron transfer, EET. It is significant because it provides bacteria with an auxiliary energy source that first enhances bacterial resilience, enabling more rapid replication, accelerated mutation, and the construction of highly durable, multi-layered biofilms. These biofilms function as fortresses, effectively blocking antibiotic agents from penetrating and reaching microbial targets. Second, this energetic reinforcement directly facilitates the development of antibiotic resistance. The bacteria not only endure, they begin actively synthesizing defensive mechanisms, enabling them to survive even the most potent pharmaceutical interventions. Moreover, even after the plastic is removed, the bacteria retain this enhanced capability. They have already mutated, adopted, and become stronger. They continue to construct resilient biofilms on other surfaces, even without the energy input once provided by plastic. For the first time, it has been demonstrated that microplastic is not merely an inert surface. It is an active participant in the development of antibiotic resistance. It alters bacterial metabolism and facilitates the selection of the most resilient and resistant strains. This means that plastic waste may be accelerating the emergence and spread of so-called superbugs, bacteria resistance to treatment. Let that sink in. Microplastic doesn't just help bacteria survive. It fuels them with energy, makes them stronger and more resilient, and thus plays an active role in the development of antibiotic resistance. This discovery fundamentally shifts our understanding of plastic pollution and makes it even more alarming. With each passing year, the problem of antibiotic resistance grows more acute. In many countries, cases are already being reported in which standard medications fail and even minor infections become difficult to treat. If we do not find a solution, antibiotics may eventually become useless. And this extends far beyond antibiotics. We are already witnessing how plastic affects the effectiveness of a wide range of medical interventions, from tissue regeneration to life extension therapies. Treatments that delivered consistent results just yesterday are now becoming unreliable. The same medications are beginning to behave unpredictably, and the underlying reason is microplastic, and more precisely, its electrical charge. It interferes with biological processes, alters cellular behavior, and disrupts signaling pathways. We can no longer rely on predictability in medicine unless we account for the fact that the body now contains a factor capable of distorting everything, from immune response to cellular memory. Today, the market, the medical field, and even some scientific circles are actively discussing supposed methods of cleansing the body of microplastic. These include techniques that allegedly remove plastic from the blood and tissues, such as plasmapheresis, hemoperfusion, mechanical filtration systems, dietary absorbents, and natural supplements claiming to detoxify the body. At first glance, the logic seems sound. If there's a toxic substance in the body, it must be removed. But the truth is, these methods do not solve the problem, neither technically nor fundamentally. Microplastic, especially in its nanoform, has already penetrated your cells, your tissues, and your neurons. It's not simply floating in your bloodstream like a guest you can politely ask to leave. It has integrated into your body. Yes, you can filter the blood, separate the plasma, and add a solution. But that solution likely contains plastic too. It leaches from the plastic IV bag, travels through the plastic tubing, and re-enters the body. We are using plastic in our very attempts to eliminate its consequences. Yes, such procedures may reduce the toxic burden, but they do not accomplish the most critical task. They do not extract plastic from your cells. They do not neutralize its electrical charge. They do not restore disrupted signaling pathways. They do not protect the brain, the immune system, or the mitochondria. If you wish, you are, of course, free to pursue all these methods. That is your personal choice. But do not indulge in illusions. This is not a solution. A real solution does not begin with external filtration. It begins with understanding what makes nanoplastic truly dangerous. The electrostatic charge is the core of nanoplastic's destructive power. It is what enables it to penetrate every biological barrier in the body, including the brain, disrupt cellular function, and compromise the immune system. It is what turns plastic into an energetically active anomaly embedded within the biosphere, one that is now systematically destroying it. And it was this very factor that the ALLATRA scientific group warned about 20 years ago. Today, our scientific group is confronting two of the greatest threats to humanity: the eruption risk of the Siberian magma plume and the proliferation of nanoplastic. Yet our work is being obstructed by circumstances and political repression. We are unable to fully pursue either of these directions, which is worsening the planetary crisis and pushing the hope of rescue further out of reach. The reasons are clear. Key specialists are being diverted to other tasks. We lack access to critical data, and our scientific team has been exiled from Russian state's repressive political machinery. Due to these barriers, even the ready-to-implement solution for degassing the Siberian plume, something I have spoken about many times, remains unrealized. This is not merely a failure. It is a deliberate step toward catastrophe, driven by someone's personal ambition. We are witnessing escalating climatic and geodynamic anomalies, including increased activity from the Siberian magma plume. Yet we lack even a basic understanding of its scale due to the absence of data. At the same time, the nanoplastic crisis, which is poisoning every one of us, is being sidelined for the very same political reasons. Time is running out, yet humanity continues to ignore these threats. When I look at other international scientific teams working on the plastic problem, one thing becomes eminently clear. They are deeply committed to helping people. However, their efforts are fragmented. Funding is minimal, and enthusiasm is suffocating under bureaucracy. Despite all of that, they are making some progress. Recent studies, particularly from China, show that nanoplastic is not merely waste. It behaves like a virus, infiltrating the bodies of human beings, including the unborn, and permeating our water, air, and soil. Its concentration is rising at an alarming rate, triggering new illnesses and accelerating bacterial resistance to antibiotics, primarily due to nanoplastic's ability to absorb harmful substances. This is now reflected in the data. The rise in neurological disorders and degenerative conditions is directly correlated with the accumulation of nanoplastic in the brain. Yet despite the efforts of individual scientists, the problem of nanoplastic is still perceived globally as a secondary issue, even as it is already poisoning every human being, along with our water, air, and soil. The climate crisis and nanoplastic pollution are not merely threats. They are existential questions for the biosphere. The presence of plastic is also influencing our planet's climate. Record-breaking temperatures and ocean warming are accelerating the breakdown of microplastic into nanoplastic, raising its concentration in the atmosphere. This vicious cycle intensifies the planetary crisis, threatening life on Earth. Ignoring this connection is nothing short of criminal negligence. Yet political games and personal agendas are squandering precious time while the world stands on the brink. Why then is there still no solution? Lack of funding. Around the world, research into nanoplastic and geodynamic crisis receives only token grants. Scientists are deprived of proper equipment and denied the ability to conduct field work. Many are forced to focus on day-to-day survival just to feed their families. This is not merely underfunding, it is sabotage of science. Absence of a global strategy, solutions implemented at the level of individual institutions are meaningless without international cooperation and large-scale investment. Willful neglect of the threat. Politicians and the media remain fixated on short-term interest, suppressing the issue. Turn on your television. What do you hear about every day? How often do you hear about the geodynamic crisis, environmental disasters, or the threat of nanoplastic? There's your answer. This silence creates the illusion that these problems will somehow resolve themselves, while the data shows the opposite. These crises have already reached a critical level, one that threatens the very existence of life. Let me put it plainly. While we fight each other for a better future, that very future is very much in doubt. Now, more than ever, science must receive maximum support. Governments have a responsibility to allocate priority funding for research into nanoplastic, particularly its ability to retain electrostatic charge. Scientists must be equipped with the tools and conditions they need to carry out their work with dignity. These individuals are laboring for the survival of humanity. Their work must be treated as a global priority. Global cooperation is essential. This crisis demands an international response. We need fundamental scientific breakthroughs across multiple disciplines. Only then can we begin the large-scale cleanup of the biosphere, prevent further contamination, and develop technology to eliminate nanoplastic. None of this is possible without united effort. Public awareness must rise. The media must actively disseminate scientific findings to break through the wall of public apathy. People need to understand that nanoplastic is already inside each of us, causing irreversible changes. Even in a small child, millions of nanoparticles have already attacked millions and millions of cells. I must reiterate, thanks to the illustrious scientific community, we now know that shielding or neutralizing the electrostatic charge can reduce the potential danger of micro and nanoplastic by at least 50%. This makes this line of research critically important. Such a breakthrough would give the global scientific community a vital window of time to develop a comprehensive approach to cleansing both our biosphere and our bodies of nanoplastic. This number one killer, which invisibly destroys not only human life, but every visible form of life around us, must be addressed with urgency. Measures of this scale can only be implemented with robust international institutional support and coordinated cross-border regulation. Delay is no longer an option. Without immediate action, humanity risks losing its cognitive capacities and facing mass casualties. Natural disasters and nanoplastic pollution are not peripheral concerns. They are the central threats to human existence. At this moment, individual scientists are making breakthroughs under conditions of minimal support. But their work will not be enough without global effort. While the world remains preoccupied with political games, our entire biosphere is nearing the point of no return. Time is running out, and we must find a solution while we still have the capacity to think. I am not exaggerating. Each year, humanity's cognitive abilities will continue to decline as nanoplastics accumulates in the brain. You already know this. So no, there is no time left. To ignore these threats is to sign humanity's death warrant. The time to act is now, or tomorrow will be too late. Life is worth fighting for.